Hey, what's up, Spaces? My name is Space Maze, and welcome back once again to another video here today, showing you some redstone circuits, just to give you a few basic tips here and there to improve your redstone. I'm gonna go through 10 of them today. It's gonna be real basic, and next episode I'll do 10 more, which will probably be a little bit harder. Anyways, most of these circuits I've used in everything I've built in my tutorials, like XP farms, my carrot farm, my every single farm pretty much, and it is really useful to know all these circuits. So we are gonna start off with the basics, and those are the OR, the NOR, the AND, the NAND, XOR, and XNOR. And after that, we will go to the R's, NOR, LATCH, T flip-flop, blah. So the first one is going to be the OR gate. And this is pretty self-explanatory. Output is on when at least one of the inputs is on. So, let's see. 2 levers, a bit of redstone. Okay, this one is on, so the output is on. We put this one on, and it's still on. We put this one off, and it's still on, but if we put this one off, it's off. And that's pretty much what a OR gate does. So if either one or both of the inputs are on, the output will be on as well. So the NOR is the other way around, and pretty self-explanatory as well. If one or both of them are on, the output is off, and all you need to do is just put a NOT gate behind it. And a NOT gate is pretty much a line of redstone inside of a redstone torch, which just inverts the power. Pretty basic. Here you go. On is off. On is off. Yeah. Off. On. Yeah. You get it, I hope. Alright, so the next one is gonna be a AND gate. And an AND gate is really useful if you want to make some sort of security door using some sort of password. Since you can pretty much hide these levers wherever you want, and I'll just explain what it does. Output is on when both inputs are on. So if I put this one on, the output is still gonna be off. But if I put this one on, output is going to be on as well. So both of them need to be on to have this powered. And how it works is pretty simple. You have 2 redstone torches on top with a redstone dust in the middle with a redstone torch. So as you can see, if both of these are on, this redstone redstone dust will be on, which will power off the torch. And in order to put this one off and this one on, you need to have both of these being powered off. So that's why you power both of them. This will be off, this is going to be turned on and on. I'm trying my best to explain everything as simple as possible. Alright, so the next one is going to be a NAND. And this is pretty much the same thing, only the other way around. All you need to do is just remove that torch and replace it with redstone, and this means that once this will turn off, it's still on, but if this one turns off as well, it's gonna be turned off. So it's pretty much a inverter of the NAND. Alright, so let's go to the next one, which is a little more, a little complicated, I guess. And it's going to be XOR or XNOR. And it really doesn't matter how you say it. XOR is pretty much the input's on means the output is on as well. XNOR means the other way around, so negative. So XNOR is on. Okay, output is on when inputs are equal to each other. I hope that makes sense. I'll just show you. It's now turned off, but if I turn this one on, it's going to be turned on. If I turn this one on as well, it's going to be turned off. If I turn this one off again, it's going to be turned off. So, or turn on, I'm sorry. So pretty much, if either one of them are on, that one will be on. But if both of them are on, it will be off. So it has to be a one input only. So the difference between an OR and a XOR is pretty much that if both of them are on, it's still turned off. But in an OR, it will be still turned on. So, you know, you can use that in a lot of things. In keys for doors, pretty much everything in Redstone. It's just a really useful contraption right here. Alright, so let's just move on. Wait, I'll show you one more design. First, let's show the Redstone bit. I'll just hang above it, and it's really easy to recreate. Yeah, there you go. Okay, let's go to the next one, which is probably a little smaller. So if you like compact, this is probably one to go. So if you, as you can see, turning this on is on. Turning this one on is off, since one of them has to be on. Then this one off means on, and etc. So let's just have a walk around, and it's really simple to recreate as well. Just the redstone, you can just see it. Just copy it, pause the video if needed. It's really simple. Alright, so another pretty complex one is a NOR latch, and NOR is not really the case. You can make it a NOR if you want to, but it's really not necessary. So let's just show you it. As you can see, I have two inputs now. And the reason for that is that a NOR latch pretty much means it's a memory device. So if either of the inputs are turned on, it will remember one of those. So let's say I turn this one on. You can see this redstone torch being turned on, and this is off. And if I power it off again, it's still off. But if I powered this one, it will actually turn around, and if I power it off, it's still there. So it's pretty much a memory card, as you can see. Just remembering what you gave to the output, or the input, I'm sorry. So another pretty basic design for that is just the use of two buttons with some normal pistons. And yeah, all you do is just press one of the buttons, now it's turned on. Press this button, now it's turned off. Memory. So another one is something I used in the past a lot. Since I didn't really know anything about redstone circuits, I used this one a lot for my XP farms. Pretty much what I did is I connected up some sort of clock towards it, and this would crush the mobs pretty much. And once the clock reached this one, it will turn off, and the mobs will be a one-hit kill. I hope you understand that. So as you can see, this one is turned on now. Now if I hit that, turned off. Now if I hit that, turn on. Easy and simple. Making it compact, just use the redstone repeaters. Boop. Oh, sorry. Need to put this one on. There you go. Off, on. Simple as that. So another thing which is kind of the same as a NOR latch, but still a little bit different, is a T flip-flop. And let me clear the weather because I don't like that. And a T flip-flop is pretty much, yeah, another memory device that acts like a toggle. So I'll just show you. If I put on this button, it will act like a lever. So let's say I push it, and you'll see this is now turned on. If I push it again, turned off. And how I made this is pretty much two sticky pistons, redstone torches above, and redstone power above, or redstone dust above. So if I hit this button, what will happen is this will turn on for just a second, which will turn off both of these torches, and the piston will retract and quickly push again. And yeah, that's pretty much how it works. There you go. So here we have another design, but using a lever. Yeah, I'll just show you. This lever is pretty much turned around to a button. And I really don't know why you would use this. I mean, there's probably some uses for it. I just haven't used it yet. But it's pretty much the same as a T flip-flop, just the other way around. So you're flipping a lever and it's making it a button. I hope that yeah, I think it's pretty self-explanatory. So here, I have a pause if you need it. Easy to recreate. No redstone dust on top. Alright, so the next one is gonna be a D flip-flop. And this is a little weird one. It's pretty much with data and write. So over here we have the write, and this is the data. So if I power this, you'll see the piston being powered. Now I'll have to power this one, and the power will go through. But now, because this is on, if I turn this off, nothing will happen, and the piston will stay up until I put this one off and this one on, then off again. I know, a little weird, but that's how it works. So turn it on, boom. You can now turn this off, and there you go. So data write. Same thing over here. Using, as you can see, a really weird contraption, since the redstone is not even connected to anything. So if I power this redstone or this sticky piston is turned on, but it needs to be updated to be able to push. You'll see if I turn this on, boom. So if I turn this off again, it's still powered until I remove this. So data write. Alright, simple, really useful for farms and such. Everything is pretty much used for farms. Okay, so here we have a clock, and you can make this as big as you want and as small as you want, pretty much, and you can change timing and whatever, whatnot. So simple one, just a clock, easy. Repeater going inside of block into redstone, blah de blah de blah. I think everyone knows that. Next one is a bit different. I don't know if a lot of people use this one, but all you need is just, this is the power pretty much. So here you have a dust, here is a redstone repeater on the third tick, and if I place this, it will automatically turn on. That easy. Alright, so the last thing I'll be showing you today is a pulse shooter. And this is pretty much pulse shorter, I'm sorry. This is pretty self-explanatory as well. Every single pulse will be shortened. So if I switch this, you'll see just a small tick going out. There you go. Another example, I've used this as well for a crusher, but then with a little more contraptions behind it. Sticky piston. So if I power this, this will be powering through this block, but the piston will be powered. You'll just see. See how fast that goes? Yeah. So that is gonna be it for the 10 redstone circuits for today. Hope you guys learned something. If you did, please leave a thumbs up. And other than that, subscribe for more, and I'll probably show you more. Also, if you have any questions at all regarding any circuit, or maybe a different way to make the circuit, because there's tons of ways, just let me know. As well as that, I can probably show everything in action using every single contraption on something, so you know where to use it for. Alright, that's gonna be it, guys. Thank you guys so much for watching, and bye bye.